Right, so we've looked at electromagnetic radiation, and we're going to look today at the dangers of electromagnetic radiation. So some of the lower frequency electromagnetic waves, such as radio waves, microwaves, infrared, visible light, those types of waves don't actually have enough energy they just mostly just pass through matter. They don't really impart enough energy onto matter to cause any serious problems. However, when you get to the higher frequency end of the spectrum, such as ultraviolet, X-rays, gamma rays, those can cause some issues because they do carry with them quite a lot of energy. Let's start with ultraviolet. Now, the low end of the ultraviolet spectrum is not what we call ionizing. However, the top part of it is. The higher frequency end of the ultraviolet spectrum is ionizing. What do we mean by ionizing? Ionizing radiation has got the potential to knock electrons out of away from their atoms. Okay, so they can knock electrons from atoms, and this is actually going to cause ions. So that's what an ion is. It's just an atom that has had an electron removed from it. Okay, ions do have slightly different properties to their just standard atom counterparts, which can cause issues, which we'll see. Now, the first one we talked about is ultraviolet. Okay, now the issue with ultraviolet is part of the spectrum is ionizing, so it can actually remove electrons from the orbit of atoms, which can cause some serious damage. Now, the sun gives off quite a lot of ultraviolet radiation. The issue with ultraviolet radiation coming from the sun is it can cause skin cancer, it can cause premature aging, that sort of thing. That's why you need to wear sun cream when you go outside on a hot day, because that will block the ultraviolet radiation. It will stop it from reaching your skin and damaging it. Okay. Now, the other two, we're going to look at X-ray, which is the next one up. Useful for seeing inside people, non-invasive imaging. So X-rays go through soft tissue like skin and muscle, but to get blocked by things like bone. Okay, so you can just see inside you. If you've got a broken bone, something like that, you can see that with an X-ray. Okay, so gamma rays and X-rays are particularly dangerous. X-rays, not as dangerous as gamma rays, but still pretty dangerous. They can cause ionization. Now, this potentially, if this happens to you, it could cause gene mutations, it could cause tumours to form, things like that. Now, most of the time when that sort of thing happens, when a gene mutation happens, that cell that has that gene mutation, it will die. But if it doesn't die, then it could potentially replicate and form cancer. Okay, so this can cause cancer. So it's particularly dangerous. Now, we can actually measure the risk associated with a particular dose of ionizing radiation, or any type of radiation, using a unit called sieverts. So sieverts is a unit of risk, basically. Okay, and this doesn't technically have to be electromagnetic radiation, but it can also be other ionizing things like alpha particles or beta particles. And this is measured in sieverts. It's a measure of risk of harm of radiation exposure. Now, most of the time you will actually see this, you won't actually see it at 1 sievert, because that is a lot of radiation. 1 sievert is a lot of risk. A NASA astronaut will be exposed to, at an absolute maximum, will be exposed to 1 sievert of risk over their entire career. Yeah, so it's a lot of radiation exposure, and you get a lot of radiation up in space, cosmic radiation, things like that. So 1 sievert is quite a lot. So often you see it measured in actually millisieverts like this, where 1,000 millisieverts is equal to 1 sievert. So when you go for an X-ray, then the doctors will have to weigh up the risk versus reward of this. So, for example, if you were injured in some way and the doctors needed to do an X-ray, they will have to judge whether or not it's worth the risk of giving you an X-ray, whether it's worth that risk of the amount of sieverts you get from that X-ray. A lot of the time it is, because they can minimise that risk in a lot of ways, but they will have to take that into account. It's a risk versus reward thing. Is it worth giving you that dose of X-rays just to see inside you? Well, most of the time it is, but you don't want to get too many X-rays in a year, because that can cause issues. Okay, that's electromagnetic radiation, dangers of electromagnetic radiation. I'll see you in the next video.